Yes, same kind of guy. Let's talk about the metabolism of some drugs. John, metabolism. Generally, metabolism is at omega carbon or the second carbon to the last carbon. Most is by omega or omega minus 1 oxidation pattern. Generally, that's it. Or you can call this one ultimate. This one penultimate. Generally, though other metabolic process can occur. For example, if this is our drug, this is our drug, we can have breakage of this bond. We can have breakage or hydrolysis at this is position 1, this is 6, at 1, 6 bond. We can have opening of the structure, though this is minor. We can have removal of all these substrates, the alkylation of substrates at position 5. You can also have demethylation at N3 or N1 in case. All these ones can occur. Again, you can have desulfuration removal of the sulfur group in case of the sulfur substituted barbiturates like the thiopento, the thiamyral, those drugs. Mainly, those are the metabolic processes. Now, let's have an example. For example, phenobarbital. Okay, let's begin with pento. Barbital. This is the structure. Here we have ethyl, then we have a 5-membered ring. 1, 2, 3, 4, 5. This is the thiopento. At first, to undergo phase 1 metabolism. Phase 1. Here will be oxidation. We shall have this. At the omega minus 1, this second last carbon, we shall have hydroxylation here. Or we can have hydroxylation at the terminal carbon atom. So we can form these two. We shall form these two. Here, the OH is at the terminal carbon atom. So this is phase 1. Again, this one can continue with phase 1. And we have this. We continue to oxidize this one. This is oxidation still. And it is still phase 1 metabolism. Remember, we form the carboxylic acid. After, this one can be conjugated. So in conjugation, that is phase 2. You can conjugate this one with either sulfate or glucuronide. Meaning that we shall have structure like this. Like this. Here, we have 1, 2, 3, 4. 1, 2, 3, 4, 5. Here, we form glucuronide. It's conjugated here. So you can form glucuronide like this. Here there is OH. Also here OH, and a carboxylic acid here. So this is glucuronide, or it can be a sulfur. If it is a sulfur, it will be like this. I mean sulfate. This is sulfate conjugation, and the drug is eliminated. Again, here, these two can just undergo phase 2. Remember, this one cannot go in phase 1 again. This one, unless if the OH is at this position. That's why this one continue with phase 1, form carboxylic acid. Now, again, both of them can undergo direct into phase 2. Phase 2. Here, we just form conjugates. For example, if this one, we shall form sulfate or glucuronide here. Or this one, we just form sulfate or glucuronide here. Same structures, just add a sulfate or glucuronide without going to the, again, oxidation to carboxylic acid. This one will form here sulfate or glucuronide, even this one. So you can see that generally it is at omega, or the second carbon to the omega carbon. Let's have another example. In case you have thiopento, this is the structure of thiopento. Here there is a sulfur, and here O. So remember, thiopento is from pentobarbital. So its metabolism, at first we shall have removal of this sulfur. When we remove the sulfur, it is replaced with oxygen. We shall form pentobarbital. Then the whole process, the remaining process remains the same. This is oxidative desulfuration. By oxidative desulfuration, we remove the sulfur, we put the oxygen, we form the pento. Then it goes through the same steps and it is eliminated. Let's have other drugs and see. Let's have phenobarbital. Phenobarbital. This is the structure. Here we have ethyl and a phenyl. This is pentobarbital. This one undergoes phase 1. Of course, it is oxidation. We shall form this. With OH here. This one can then undergo phase 2. Phase 2 metabolism. That is conjugation. So we form this. Now this one can be conjugated with glucuronide. With OH, 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 and OH. Or by sulfate. So we have here this with sulfate. Now these ones, they are highly water soluble. They can be eliminated in urine. Again, we say that also we can have here breaking of the ring. This ring can break. Let's see how it happens using this same phenobarbital. Remember, drugs like now methabarbital can undergo same mechanism, but for it, remember, doesn't have this, so can be hydroxylated and follows the same mechanism like the pentobarbital. Then for methylbarbital, it has phenyl and a methyl. It can be demethylated. Then this one can be hydroxylated and follows the same route for methylbarbital because it's almost same structure. Just the other one has a methyl here. Demethylation follows the same route. Let's see how we can break the ring. Yes, let's see the breaking of the ring using the phenobarbital. This is phenobarbital. By hydrolysis, That is still phase 1 hydrolysis. We can form this. Here, this one is N, it will be NH2. We are breaking here. And here we shall have this. And this one will be OH. This ketone, this one is this O. Then here we have formed the OH group. Now, still by hydrolysis, we can lose this one, the NH2, form this. We have this NH present, O with a phenyl present, and still we still have this OH. Now here, after removal of this one by hydrolysis, we have formed another OH group like this. And here we can lose carbon dioxide, we form this. Here there is a phenyl ring, and this one is present with OH. Here we have this NH. Now it will be NH2. This one is lost. Here, this one can be hydrolyzed again, form this with OH. And here you have this. With OH. Now this one can be eliminated. So those are the general metabolic pathways for these barbiturates. Let's see the general pharmacological actions and other pharmacological actions of these barbiturates.